Hi, welcome to this video. This is Leetcode 209, minimum size subarray sum, and it uses a technique called sliding window. So this is a technique where you're looking for a subarray of an array, and that subarray could grow or shrink either from the right side or the left side. So we're going to take a look really quickly at the code, and then we're going to take a quick look at a run through. So the main thing that you want to do in this particular problem is that you're going to get an array of a certain size, right? It could be A, B, C, D, E. Now, based upon the criteria of the problem, you're going to be looking for a particular subarray. A subarray will be a contiguous area of the array. In this particular line, we're looking at the subarray that contains the letters B, C, and D. And it's possible that to find the optimal solution, you have to grow the window to include E, and then you check, and then maybe it's possible that after you include E, you don't need B. So that's what sliding window is. The window that might cover three elements might include B and it might include E, and it just slides from the left side to the right side. But it's possible that a solution that originally had B, C, and D, when you include E, that does become the optimal solution. So the way this works is that you create a pointer called left pointer, and that holds on to basically the left edge of the window. And so that pointer is basically just an index number. And because this problem deals with an array, what you want to do is you want to loop through the array, right? And when you loop through the array, you're going to add whatever number you get at each element to a sum. And so what happens is you want to be able to find the shortest subarray with the target value that they give you. And once you find that, that's when you start sliding. And so basically you will compare to see what happens to the current window length, which, maybe it's 3, maybe it's 4, depending on where you are. And you match it with this variable that you saved up here to see what you want to do with it. It might make more sense if we just take a look at an example right now. So first we get the array. And so what the problem was really asking is saying, okay, find me a subarray that can give me the sum of 7. So obviously for this particular array, the subarray is going to be 4 and 3, right? Because it equals the target. It's obviously possible that you could have this problem where maybe the 3 numbers will also give you 7. I mean, not in this case, because that gives you 6. But suppose that gave you 7, and this also gave you 7, you will want to pick this one, because you want the minimum size subarray. So, if we take a really quick look at the variables that you want to keep track of when you do a problem like this, you want to keep track of the index. Right here, you want to have a running sum. Usually I like to call it running sum, but you have to get used to the idea that running sum and sum is the same thing in this problem. And then you have the result. The result is basically the best result you have so far. And then the left pointer is how you keep track of the sliding window like we talked about earlier. So that's basically what you need. And then when I equals 0, this is what we're going to get, right? When I equals 0, you have the current value of 2, which is right here. And then the sum means that you have to add it together. And then you want to look to see if the sum is less than the target. Maybe it will help if we look at the code that you need right now. So the top line is you run through the array, and then you find out what the current value is, which we do right here, right? And then you add to get the sum right here. And then you check to see if the sum is greater or equal to the target. Okay, in this case it's less. So we do nothing when we move on. And you go to step 1, right? Let me blank out step 0. At step 1, I is right here, and the value where the I pointer is at is going to be 3, right? So you add 3 to the sum, you get 5. Is the sum greater than the target? No. So again, we'll keep going. Let's blank out step 1 and go to step 2. So previously sum was 5, okay? Previously. Now I has moved up to 2, and the value of I is 1 right here. And so we add 1 to the sum, and we get 6. We check to see what the sum is compared to the target. Is it greater? No. So we continue. Let's blank out step 2 and do step 3. Here's where it's going to get a little bit more complicated. So let's take a look at the current value at where I is. Current value is going to be 2, right? Because I is right here, points to 2. And so previously the sum was 6. We add the current value of 2, we get 8. Now we check. Is the sum greater than the target? Yes. So let's continue. Well, what's the next step? Well, you want to see what is the current value of the sliding window. Well, the sliding window, because we're inside this while loop now, right? So you have to figure out what the sliding window length is. It's going to be I minus a left pointer plus 1. You do the plus 1 because it's an array that's 0 indexed, and so I is currently the value of 3, right? We have I right here. 0 is where the left pointer is, so 3 minus 0 plus 1 is 4. So you see this is, visually, you can see the length of this, and you know it's 4, okay? And so you have to do this step where you check to see the result. We hadn't done anything with the result, so far it's a really, really, really large number. And if you compare the minimum of result, which is a large number right now, with a current window length that's 4, you take the minimum, so you end up with 4, which is great. So you know you can update result, and you see what the next step is that after you update the result, you have this line right here, right, where you take the sum, and you subtract the value at the left pointer, which is going to be 2. So sum is going to be 8 minus 2, and you're going to get 6. And then you're also going to do this line right here, left pointer plus plus, meaning you're going to get rid of the leftmost value right here and just see if the remaining sliding window at 3, 1, 2 is still going to be enough to be greater than the target. Okay? Because what you really want to think about is, suppose that the value that you add here, the most recent value, suppose that value is really large, like 200, then you wouldn't need anything in front of it. You're always going to be larger than the target right here. And so that's why you do that. That's why you slide the window. And that's the really important part that you want to understand in this question. So if we look at the next part, and basically I had this, this is why you increase the left pointer down here, and then you try to see whether or not that sliding window is still enough to meet. And we see that it's not going to be because it becomes 6. So let's blank out everything for step 3 and look at what happens when I becomes 4. So when I becomes 4, what you do is you check the current value, right? Value is 4. And then you add that to the sum, which previously was 6. So now we get 10. And you see sum is going to be bigger than the target. So we continue into our while loop right here. You calculate current window length, which visually you can see is 4. And then you check to see what the result's going to be, right? So you see currently the sum is 10. And then what is the value being pointed to at the left pointer? Well, the left pointer is at 1, right? So you're going to subtract the value 3. So 10 minus 3, you're going to get 7. All right? So we know that sum will become 7. And then you're going to increment the left pointer so that it becomes 2. Meaning that you are going to subtract that part of the window and see if just the frontmost part of the sliding window gives you everything you need. So we're going to take a look at that really fast. The next step. So now we see that you continue in the while loop, right? And because you check to see if the sum is greater or equal to the target, the answer is yes. So we continue. We check the value of result, which is 4 right here. And current window length, which you can visually see is 3. And so you're going to take 3. So you know that the result is going to become 3 at the next part. And then you continue and you check out what sum is supposed to be because you need this line. And you see currently sum is 7. And then the value being pointed to the left pointer is at 2. So 2 is right here. So value is 1. So 7 minus 1 will give you 6. But you still have to increment the left pointer. Alright? So when you do that, you're going to see that, okay, well, you're going to jump out of this while loop. Because then sum becomes 6. And is it larger or equal to the target? No. We're going to get out of here and go to the next step. Here's step 5. So we see that I has incremented to 5 right here. And the current value being pointed to at I is going to be 3. So we add 3 to the sum, right? Now we have 9 as a sum. Now, is the sum of 9 larger than the target? 7? Yes. So let's do a little work. Now, you get into the while loop, right here. Calculate the window length, right? So we see that the left pointer is pointing to I of 3, and we're currently at 5, so the window length is going to be 3, right? Well, hey, the result right now is also 3, which we wrote down here, so you stay at 3 over here. You still have to do the line where you subtract the sum because you have to move the window, right? So you're going to subtract that, and the way you do that is you take off the value, what is being referenced at left pointer, so at index of 3, right? 3. So you subtract 2. So we subtract 2 over here, and you see 9 minus 2, you get 7. So we know that sum will get updated to 7, and actually our while loop will continue again over here. Meanwhile, you increment the left pointer, because we say we have to do that, meaning that the left pointer is going to become 4. Left pointer will come up to here, right? That's the left pointer. So let's take a look at what happens next. What happens next? Well, because you're still in the while loop and the sum is still 7, right? You say, okay, well, we continue. Then we check the result right now is 3 right here. And you check the current window length. Well, you know that left pointer is at 4, right? Left pointer is at 4. I is at 5. So you know that the current value of the window is 2. Because you wanted the minimum, you're going to take 2. And so you look at the sum, because after you do that, you have this line where you subtract, and left pointer is currently at 4, right? So you can actually take out the value 4. So 7, which is the sum, minus 4, you get 3. So you know you're going to bust out of the while loop. Left pointer plus plus. So that's going to decrease the window, but it doesn't really matter because you've reached the end of the array. And so when you jump out of this code, what you're left with is that the best window, best result so far is 2, because that is actually going to get updated here, and that's what you're going to return. And so if we take a look at the code again really fast, it might make a little bit more sense. And so earlier we were talking about that, you want to keep the result, which here actually in the code I had called it previous low of sliding window length right here, because that was the previous smallest length. And the sum, which we said could be called running sum, but for the sake of clarity, and if you're writing this code during an interview, shorter variable names will help you out on the whiteboard. And the left pointer, obviously you could just call it left, and that's how you shrink the window, right? And here, of course, is how we go through the array. And so the while loop, again, is what you do when you hit your sum. And of course, you check out the window length currently, then you find the minimum, then you decrease the value based on what is being pointed to at left, and then you actually make the window smaller right here. And then at the end, if this variable that we initialized earlier is not its default value, then we return what we found in our for loop. Okay, just like that. And so that's what we're talking about right now. That's Leetcode 209, minimum size subarray sum, and it's using the technique called sliding window. Thank you very much.